Hello, everybody. These are your notes for types of forces. So we're starting a new unit, and I want you guys to go and find this table. It can either be in your weekly module or your physics notes. So starting from the left-hand side, we're going to talk about forces. So force is a push or pull. So push the door, pull the door, that's a force. This is something that you should have learned in junior high, but we're not going to hold you accountable for that. So just remember right now, a force is a push or a pull. And these are the types of forces. So you can have an applied force, a normal force, tension, gravity, friction, and air resistance. And these are the forces that we're going to cover in our class. These are the symbols that you're going to use when you draw your free body diagrams, and don't worry about what that means just yet. Just know that this is the symbol for each one of those forces. So F sub A is an applied force. What that means is that it's a force that is by a person or a living thing. And it's always in the direction of the push or pull. So in direction of push or pull. So think about, like, if you're opening a door, you're going to pull it towards you. So then that's the direction of your force. If you're trying to, like, she's pushing a cart, she's pushing it away. And that's what you need to think about when it's an applied force. So the visual is just think about it's a person pushing a cart. So she is applying a force to move this cart. The normal force is F sub n, and it is present when there is a surface. That surface is usually the ground. It's this force in the direction of this force, is going to be perpendicular to the surface. And I like to remind students, just so they keep something in mind, that it's normally up. All right, so just remember this is going to be normally up for the case of our class. The next one is tension, F sub T. So this is like a sub letter. This one is going to be present when there is a rope, string, or wire. And similar to, I'm just going to copy and paste, I'm going to highlight the applied force because it's similar to the applied force. It's also in the direction of the push or pull. So if you think about her here as she's hanging on the trapeze, which way is the tension holding her? So think about that. Which way is the tension holding this lady? And the rope is actually holding her up. So the force here, the tension force, would be up because that's the way that it's holding the girl. Moving on to gravity, the force of gravity is actually known as the weight of the object. Weight of an object. And your weight is the amount of force that is exerted on you by the planet. So the force exerted on you by planet or astral body, or because sometimes we'll talk about the moon, aka the moon. And this one is always going to be down. So every time you see the arrow pointed down, it's usually, it's going to be gravity. So this one is straight down. And friction is something that some students every now and then question, like, oh, well, how do I know if there's friction? And I want you to rub your hands together for a second and feel the heat of your hands. The heat is caused by friction, okay? And this is going to be present when there is a surface and object is moving. All right, and this is going to be opposite to motion and parallel to surface. And of course, I'm assuming that Frankenstein is running on a surface here. So if he's running to the right, then friction is to the left because that would be opposite to his motion. And then air resistance. Air resistance is actually a type of friction. Oops, wrong thing. This is a type of friction. And it is caused by the molecules in the air. So if you spread your hand out and try to pretend like you're going to fly, you could feel that wind. That air is caused by, or you feel that air from molecules, and that's what causes air resistance. And this is also going to be opposite to motion. So the skydiver is going to feel wind up as he's falling down. Air resistance is affecting his body up because it's opposite to the way he's falling. And that's it for your notes for today. After this, you want to go into the matching. So try to use this note card, quote unquote, digital note card, to figure out the type of forces and match the free body diagram.